Can you spur off a spur? Most electricians are going to answer that instantly.
No.
But then if that was completely true, then why do fused spurs exist? And are there any hard and fast rules that stop us from doing it? Like the regs, for example. I mean, how many times have you gone out to fit an extra socket for a customer, found a socket you can spur off, to find that that socket is a spur? There's no other socket locally to spur off, and extending a ring or radial will leave a lot of cable strain in the back box. Also, in the last video, I said I took 2 spurs off a single point. But you're not allowed to do that, even though I just did. So before we dive into those answers, let's just quickly remind ourselves, what is a spur? A spur is simply a branch taken from a point in a circuit. There are rules on what circuits we are allowed to spur off. For example, you can't spur off a distribution circuit because you could overload the cable. It's socket circuits that we commonly spur off, both ring and radial circuits. But we have to be very careful because a spurred point in any circuit has the potential to cause significant damage if not done correctly. High resistant joints, screwed terminations left inaccessible, and incorrectly rated connections can all lead to overheating and the potential for fire and shock, so should only be carried out by competent persons. So what does the regulation say about spurs? To understand this, we need to look at Appendix 15 of BS 7671. Appendix 15 provides guidance on the design of ring and radial final circuits. It explains how ring final circuits are intended to operate and how spurs can be taken from them. Appendix 15 explains that a ring final circuit wired in 2.5mm² cable and protected by a 30 or 32 amp device can supply socket outlets over a floor area of up to 100 square meters. The reason this works is because the ring provides 2 parallel paths for current to flow. So under normal conditions, the load is shared between both legs of the ring. If you want to find out more about how load sharing works in a ring final circuit, then check out the previous video I did. I've left links for that in the description. So under normal conditions, the load is shared between both legs of the ring. But when you take a spur from the ring, that changes the situation, because that spur now relies on a longer path back through the circuit, which means the resistance of the cable increases, and that can change how the circuit behaves under load. So electrically, it behaves more like a small radial circuit connected to the ring. But if we then start adding further sockets onto that spur, the problem grows. Each additional socket introduces more cable, which means more resistance is added into that path. So now, if multiple loads are plugged in, all of that current has to travel through that increasing resistance, and that can result in the current exceeding the safe current carrying capacity of that cable and exceeding the permitted maximum earth fault loop impedance for that circuit. Appendix 15 therefore places limits to how these spurs can be used. It states that an unfused spur should supply only one single or one double socket outlet or one item of permanently connected equipment. This is intended to prevent excessive load being placed on a 2.5mm cable, because remember, the ring final circuit itself is protected by a 30 or a 32 amp protective device. That is far higher than the current carrying capacity of a single 2.5mm² conductor under many installation methods. So the limits placed on unfused spurs are really about making sure the conductors remain properly protected. So why is it then that we can't spur off a spur? Well, the difficulty is control. When we install a spur, we have no control over what might be plugged into that outlet in the future. One socket might only ever supply a television or a phone charger, but if that socket then supplies another socket and perhaps another again, the total load could increase significantly. All of that current could now be flowing through a cable that we can't see. That cable might be run behind plaster, under floors, or through insulation. So if the load becomes excessive and the conductor begins to overheat, there may be no obvious signs that anything is wrong. The cable insulation can begin to deteriorate, connections can start to degrade, and the first indication of a problem might only appear once the damage has already occurred. This is exactly what the limits in Appendix 15 are trying to prevent. So what happens if the only socket you can come off is already a spur? Is there a solution? Well, yes, there is. Let's have a look at this real scenario. This socket is in the dining room that already feeds a spur through the wall into the conservatory. Now the customer wants a little bit more. They want an outdoor socket. They also want power for the conservatory lighting. So what can we do? The first step was confirming that the dining room socket was actually part of the ring final circuit. Once we knew that, we could safely take a spur from that point. But instead of feeding straight into a socket, we installed a fused connection unit. The fused connection unit becomes the control point for everything downstream of it. From the load side of that fused connection unit, we supplied the conservatory socket, the lighting supply, and the new outdoor socket, because everything beyond that point is now protected by a 13 amp fuse inside the fused connection unit. And that fuse is not not there to protect the sockets, it is there to protect the cable, the part of the installation we can't see. So the conductors supplying the conservatory, the lighting and the outdoor socket can never be exposed to the full capacity of the ring final circuit. That is why we can safely use smaller conductors beyond that point. So, can you spur off a spur? If the spur is unfused, then Appendix 15 limits you to one single or double socket or one piece of permanently connected equipment. Extending that spur further runs the risk of putting additional load onto a cable that was never designed to carry it. But once a fused connection unit is installed, the fuse limits the current flowing into the downstream wiring, which means the conductors beyond that point are properly protected against overload. Now, in the last video I said, wait, 2 spurs off a single point, you can't do that. But I did. So why can we take 2 spurs off this single device? Well, we are allowed to spur as many times as we like from a ring or radial, as long as the number of spurs is less than the sockets on the circuit. And each spur should be taken from a separate point on that circuit. And the way that the QuickWire works is, the circuit enters one side of the connector and leaves the other. So electrically, the ring or radial continues through the device, which means this side becomes one point of the circuit, and this side becomes another point on the circuit. They are treated as 2 separate spur points. And that is why. And because it is rated as a maintenance-free connector, it can also be installed in locations such as floor voids where access may not be possible later, which makes it a very tidy solution when you need to distribute a supply without overcrowding terminals or installing additional junction boxes. But what do you think? Are spurs a gateway to electrical DIY hell, or a handy installation tool that you can have in your back pocket? I'd love to hear your comments and your stories of DIY spurs gone wrong. And if you want to find out more about QuickWire and how they are changing the face of maintenance-free connections, then hit the video on screen now.